Hey everyone, Mr. Nicholson here. I'm going to do examples 3 and 4 for you. Mrs. Gerber did a nice job on examples 1 and 2. So let's look at 3 and 4. So the difference between these two and the first two is that rather than being given a set of numbers in a sequence, we're being given the formulas. So, which at first might be a little daunting, unless, like I'm sure you all did, you read through the sequences reading. And when you get to the bottom, we have our explicit formulas summarized for us nicely. So if you look at these two formulas and then you compare them to the examples, you can see that example 3 matches pretty well to the explicit formula for an arithmetic sequence. Okay, and then if you look at geometric, you can see that that one has the same format as example 4. The other way to look at these, though, the idea behind arithmetic sequences is that they add the same number every single time. So like example 1, you added 2 every single time. Here, that number 3 in this equation is what we're adding every single time. So if you were to try and create the sequence, I just picked n as 1, 2, and 3, you would get 34, 37, and 40. So you can see the numbers are adding and increasing at the same rate. Now here we have 100 times 1/2 to an exponent. And the idea there, if we wanted to look at this not from an explicit formula, but actually graphing it, we would get, well, if n is 1, we get 100, and then 50, 25. I was going to go through and do larger numbers just to see, but just to keep it short and sweet here, I'll just look at those. So if you memorize the formulas, that's great, but you can see that if you were to type these into a graphing calculator, which I thought I had open, you'll see that anytime your graph is, well, let's just graph this one. If it looks like an exponential graph, that is another good way to tell that something is geometric. So it's either going to exponentially grow or decay. If it is a straight line formula, I guess I could pause the video and do that. But if you were to graph this, it would come out as a straight line. Okay, so your slope is constant like that. So that's it for examples 3 and 4. If you can identify it by the exact format of the formula, that's fine. Otherwise, it says feel free to use your graphing calculator. Do exactly that. Type it in. If you get a straight line for your graph, you're talking arithmetic. If you're looking at something that looks similar to more of an exponential growth or decay, you're looking at geometric. So that's it. Thanks. Have a good day.